Okay, dear students, today our topic mainly on trigonometric equation, and I will show you some tricks on solving trigonometric equations in many important problems in JEE mains and advanced. So mainly trigonometric equations is a very important part of your trigonometric functions. Actually, there will be some trigonometric very complicated equations maybe, or maybe very simplified equations. You need to factorize the thing, so I will give you step by step what are the methods we adopt to make you understand. So first of all, I will go to the what are trigonometric equations. The equations containing trigonometric functions of unknown angles are known as trigonometric equations. Just like if you say cos theta equal to half, this is a trigonometric equations. Okay, you can say cos theta is equal to half. So, or sin theta equal to 0, this is also trigonometric equations. Maybe some complicated power is there. So this type of theta is unknown, you don't know the angle theta, so this type of equations are called trigonometric equations. Now what are the solutions of a trigonometric equation? A solution of a trigonometric equation is the value of the unknown angle that satisfies the equation. So if cos theta equal to half, you can very quickly answer the value of theta will be pi by 3, 60 degree. Okay, cos 60 is half, so you can quickly answer the value of angle is theta equal to pi by 3. So this is called the solution of the, so not only pi by 3, you can have many values of theta, because you know trigonometric functions are periodic in nature. You know the graphs of trigonometric functions, those are periodic in nature. So this cos theta equal to half for theta equal to pi by 3. So if you draw the diagram, I will show you here. So if you draw the diagram here, and this is your cos, this is the periodic function. Okay, this is the periodic function, and you see half, if you can draw the line y equal to half. Okay, this is your y equal to half line, and you see not only for pi by 3, this is your pi by 3, not only pi by 3, you have pi third quadrant. Okay, also there are so many angles for which y equal to half, that is cos theta is equal to half for so many values, pi by 3, 2 pi minus pi by 3, it is 2 pi minus pi by 3, 2 pi plus pi by 3. So there are so many values of theta for which you satisfies this value, this equation. So those values are called the solution of a trigonometric equation. Okay, so that is the main concept of trigonometric equations. I will get those values actually, and those values are called the general values. And if you are in 0 to pi by 2 or 0 to 2 pi, those values are called the principal values. So because of the periodic nature of the trigonometric functions, we have so many values. Okay, everybody, we have so many values. Now, so in the same way, we have some angles, some values, some general values actually. So there are some prerequisite before we go to the problems. So these general values are developed using the concept of that periodic nature. So if sin theta equal to 0, theta equal to n pi, n is an integer, n is 0, plus minus 1, plus minus 2, etc. So you know that sin theta equal to 0, then for theta equal to 0 it is 0, theta equal to pi it is 0, theta equal to 2 pi it is 0. So these are all, there are infinite number of values. So those are actually written in a very compact form, and that compact form is theta equal to n pi. If cos theta equal to 0, theta equal to 2n plus 1 into pi by 2, that is also very compact form. If tan theta equal to 0, theta equal to n pi. So these are written in the compact form. So this is the first set of prerequisite. We need these things in calculation. If sine theta equal to 1, then theta equal to 2n plus 1 into pi by 2. You know that for theta equal to pi by 2, sine pi by 2 is 1. For theta equal to 3 pi by 2, it is minus 1, obviously. But for 5 pi by 2, it will be 1, like this. And cos theta equal to 1, then theta equal to 2n pi. And the most important one is, if sine theta equal to sine alpha, then theta equal to n pi plus minus 1 whole to the power n into alpha. This is for sine. This is the general values for sine. So in that case, if you have cos theta is equal to half, suppose, so that is cos pi by 6, 30 degree, half. So you have to write theta equal to n pi. In that case, you have to write theta equal to n pi plus minus 1 whole to the power n times pi by 6, because you have sine theta equal to half. You have to write the general values, not the principal values. So that is equal to sine pi by 6. Okay. So in that way, you can write the general values. That means you want to combine all the values, all possible values, and n is an integer. So you have to mention that n is an integer. And if cos theta is equal to cos alpha, theta equal to 2n plus minus alpha, 2n pi, sorry, there is a typographical error. It is 2n pi plus minus alpha. And if tan theta equal to tan alpha, then theta equal to n pi plus alpha. So these are the very important formulae that we will use in the problems. So that is the basic concept of general solution. Mainly general solution, actually the combined or more compact form of the solution. You are writing the principal solution. No, I am just combining all the solution using n, the integer. So you are combining all the solutions. There are infinite number of solutions. And these solutions came from the periodic nature of the trigonometric functions. Okay. And already we have explained this graph. So that look at that, y equal to half. This line cuts the cos x graphs at so many points, infinite number of points. So these are all actually the general values. Okay. Now let us start with the problems analysis. How to deal with the problems of JE. Okay. So first problem is, look at the problem. Cos 3x, cos cube x plus sine 3x, sine cube x equal to 0. And you have 4 options A, B, C, D. Now how will you answer this type of problem? You have to find out, solve means you have to find out x or theta. Here you have x, so you have to find out x. Now cos cube x. So if you have a cos cube x, you have to recall the formulae for multiple angles. What is the formula for multiple angles? You know that cos 3x, there is a formula for cos 3x, 4 cos cube x minus 3 cos x. Okay, that is the formula for cos 3x. And from here you can write cos cube x equal to, from here you can write cos cube x equal to cos 3x plus 3 cos x. Sorry. It's gone. Just a second. Let me have that screen. Okay. Yeah. So it's due to some network problem. It's gone. Don't worry. I will explain. So I was in the problem actually. Yeah. Cos 3x. So similarly, you have the formula for cos cube x. What is the formula for cos cube x? Cos cube x you can write 1/4 of cos 3x plus 3 cos x. Okay, plus 3 cos x. That is your cos cube x. Okay, and similarly you can write sine cube x. Sine cube x is 1/4 3 sine x. This is all for multiple angles, minus sine 3x. Okay, so we have to remove that sine cube x and cos cube x from the solution. So for that we need, yeah, we need a space. So you substitute these values here. So if you substitute, you have cos 3x times 1/4 of cos 3x, sorry, okay, plus 3 cos x and plus sine 3x times 1/4 3 sin x minus sine 3x, okay, equal to 0. Okay, just you have plugged in this cos cube x and sine cube x, that's it. So you have to identify how will you tackle the problem. So here cos cube and sine cube, this type of complicated term you have to eliminate. So eliminate it, and if you simplify, quickly, you have to simplify 1/4. This will be your 3 cos 2x, because you have cos square 3x and cos square 3x and minus sine square 3x, that will be your cos 6x. Cos 2x formula I am applying, cos 6x plus, you have cos, if you take 3 common, then 3 cos 3x cos x plus sine 3x sin x. So cos a cos b plus sin a sin b, that will be your cos a minus b, so cos 2x. So this is the simplified form. You look at that, equal to 0 you have on the right hand side. Now again you can apply, this is nothing but your 3 cos 2x cos 6x, okay. So you look at this formula, this is cos 3x 3 cos x, so this is cos cube x. So this, look at the cos cube formula, cos cube x is 1/4 cos 3x plus 3 cos x. So in this case you have cos 6x 3 cos 2x, so you can write, definitely it will be simplified to cos cube 2x, okay. It is cos cube 2x formula, using that formula, and 2x is actually the theta. So if cos cube 2x is 0, then cos 2x equal to 0. And look at that, go to the general formulae. So you have cos theta equal to 0, then theta is 2n plus 1 into pi by 2. 2n plus 1 into pi by 2, that's it. So you can write that if cos 2x is equal to 0, 2x equal to 2n plus 1 times pi by 2, okay, and n belongs to the integers, okay everybody. So this is x equal to 2n plus 1 times pi by 4, that's it. This is the general solution. So look at the options, yeah, you have b, so b is the correct option. B is your answer. This is the problem 1. Let's go to the problem 2. I will solve so many problems for you. Obviously, after that, I will clear your doubts. Okay, next is sine to the power 4 plus cos to the power 4 is equal to sin x plus cos x, sin x cos x in this interval. Look at the interval 0 to 2 pi. Okay, if it is interval is given, you have to find out the specific values of x, substituting n equal to 0, 1, 2, etc. I'll show you. Okay, now quickly, if you solve this, if you simplify this, sine to the power 4 plus cos to the power 4, you will get sine to the power 4 plus cos to the power 4, you will get, if you apply sine square x whole square plus cos square x whole square, that a square plus b square, if you apply the simple algebraic manipulation, then it will be looks like 1 minus 2 sine square x cos square x, okay, equal to, on the right you have sin x cos x, so you can write sin 2x by 2. Simply you can write sin 2x by 2, okay. Now this is nothing but you can write this is as 1 minus, using multiple angles, again multiplying with 2 and half, taken half, sin square 2x by 2 equal to sin 2x by 2, okay. Now if you If you simplify, this is a quadratic. If you simplify, you have sine squared 2x. It is a quadratic in sine squared 2x plus sine 2x minus 2 equal to 0. So if you do the factorization, this is by factorization. So solving can be done by factorization or by Sridhar Acharya, whatever. So this will be sine 2x plus 2 times sine 2x minus 1. Okay, sine 2x minus 1 equal to 0. So sine 2x equal to, no, cannot be, this cannot be, this is absurd. Sine 2x cannot be minus 2. This will give you absurd value. So it's never be possible. So sine 2x equal to 1. So if sine 2x equal to 1, again from the formulae, you can write 2x equal to 4n plus 1 into pi by 2. That is from the general solution formula. Okay. And you have finally x equal to 4n plus 1 into pi by 4. Okay. Now this is not the final solution because you have to find out how many solutions are there, and your interval is 0 to 2 pi. So if n equal to 0, you have to start from n equal to 0. N equal to 0, look at that, x equal to pi by 4. That satisfies the range. That satisfies this range 0 to 2 pi. Okay. So you will consider this value. You will consider this value. N equal to 1. So if n equal to 1, x equal to 5 pi by 4. Okay. This is also, these two values are satisfies in this range. But you just check. If you substitute n equal to 2, then it will be 9 pi by 4. 9 pi by 4 is more than 2 pi. It is more than 2 pi. What? Okay. It exceeds that range. So you have only two solutions. You have only two solutions satisfying that range. So your option will be, look at that, your option will be A because you have 2. 2 is the answer. Okay, everybody, this is a problem of solution of problem 2. Let's move on. Let's come to problem 3. How will you solve problem 3? Problem 3 is modulus of cot x equal to cot x plus 1 by sin x, and here also the interval is given 0 to 2 pi. So the number of solutions of the equation, you have to find out the number of solutions of this equation. This is also very, very important because you have modulus. Now look at that. What is I will explain once again what is modulus of x. Modulus of x is simply x whenever x greater than 0, x is positive. So modulus of x is x when x is positive and equal to minus x when x is negative. That's the basic definition of modulus. Okay, everybody. Now mod cot x, in that case we have to deal with two cases, if cot x positive or cot x negative. So let's show you, let me show you. Yeah, this is how. So if cot x positive, if cot x positive, okay, then you have, if cot x positive, then mod cot x is cot x. So cot x cancel from both sides and you have 1 by sin x equal to 0. And that is impossible. Okay, that is absurd, not possible. Okay, let's move to the second case. If cot x less than 0, if cot x less than 0, you on the left you have mod minus cot x, modulus will be minus, and you have this is equal to cot x plus 1 by sin x. Okay, so just replace your sin cos, just replace in terms of sin cos, it will be 2 cos x plus 1 by sin x equal to 0. And simply you have cos x is equal to minus half. Okay, so cos x is equal to minus half. That means the angle will be in the second quadrant. Second quadrant. Okay, so minus half, the value of angle will be 2 pi by 3. Okay, cos 2 pi by 3 will be pi minus pi by 3. Pi minus, actually it is pi minus pi by 3. So pi minus 2 pi by 3 is minus half. So you have the general values, x equal to 2n pi plus minus 2n pi plus minus 2 pi by 3. That comes from the formula for general solution. N belongs to z. Okay, that's the solution. But what are the values actually you have to find out in that range? So if n equal to 0, your x is equal to 2 pi by 3. You have to take the positive one. Just taking the positive, because the range is 0 to 2 pi. Okay, 0 to 2 pi, and cot x is negative, satisfying these two conditions actually. Satisfying these two conditions. Look at that very carefully. This is the case for cot x less than 0. So in the graph, you have to find out where cot x less than 0, and you have to consider that value of x that will satisfy 0 to 2 pi. So only value is 2 pi by 3. If you take other values, that will be not cot x, in that case not negative, and that will exceed 0 to 2 pi. So this is the only solution. So you have only one solution in this case. So let's go to, so your answer will be B. B is the answer because of this reason. This is the explanation. Okay, everyone. Let's move on to problem number 4. Okay, that's very interesting problem. You have tan theta plus tan 4 theta plus tan 7 theta. So what I'm using actually, I'm using the previous formulae. You are using compound angle, you are using sums and products, you are using multiple, submultiple, all the things are required here. So tan theta plus tan 4 theta plus tan 7 theta equal to tan theta, tan 4 theta, tan 7 theta. You have to solve this. Okay. Now guys, how will you solve this? You have a trick for this trigonometric right. You can write that. How? Let me write. You can take this tan 7 theta to right hand side, transpose this tan 7 theta to right hand side, and write it as tan theta plus tan 4 theta equal to, if you take, so that will be minus tan 7 theta common, and you have 1 minus tan theta tan 4 theta. Okay, that's it. So you have tan 7 theta into times this one. Okay, let me write in a fair space. Let me take, yeah. So if you take that tan 7 theta on the right hand side, so it will be tan theta tan 4 theta equal to minus tan 7 theta times 1 minus tan theta tan 4 theta. That is the simplified form. Okay, now if you cross multiply, that is, you take this one to the denominator of this, so you have tan theta plus tan 4 theta over 1 minus tan theta tan 4 theta. That's it. That is the form, and this is the usual compound angle form, and you have minus tan 7 theta on the right. So you can write, so that you can write tan of my, I'm just writing reverse in a reverse order. So I'm writing tan of minus 7 theta equal to tan 5 theta. Okay, or tan 5 theta equal to minus. So in the for the tan, what is the general formula? What is the general formula for tan? Let me show you. Let me show you guys what is the form of the general solution of tan theta. Look at that. If tan theta, last one, look at the last one. If tan theta equal to tan alpha, then theta equal to n pi plus alpha. That's it. So you can write that. So we can write, here it goes. So we can write tan. So let me write directly the general form. 5 theta equal to n pi minus 7 theta. Okay, or you can write minus 7 theta is equal to n pi plus 5 theta, whatever. So you have ultimately, what is your theta? If you simplify, you will get n pi over 12. That's it. That's the solution. That's the solution. You will think this is the solution. No, guys, this is not the solution. Why? Why? N is an integer. Look at that. If I substitute n equal to 6, what is the value of theta? Theta will be pi by 2, and tan pi by 2 doesn't exist. Tan pi by 2 doesn't exist because you have tan pi by 2, so that doesn't satisfy. For n equal to 6, it doesn't satisfy the equation because tan pi by 2 is undefined, infinity. So this is not satisfied. So no value for n equal to 6. What about n equal to 18? Also you have 18. So you have theta equal to 3 pi by 2. So again you have the same problem. What about n equal to 30? So you have the same problem. These values, for these values of n, theta doesn't exist. So there is no solution actually in this case. So your option will be not A. So maximum student will answer A, but A is not the answer. You have to cross check that if there is any n for which this is not satisfied, you have to find out n that. So your option is none of these. So none of these is a very dangerous example, dangerous option, dear students. If you have none of these, then be careful while you are solving the problems of JEE. So none of this can be the solution. None of this can be the options. Okay. So this is very, very important case. I want to share with you. None of this. In this case, your none of this is the option. There will be many problems where the examiners has to set the options in none of this. So n pi by 12 is not the answer, but the answer is there is no solution because for these values of n, the solution doesn't exist. Okay, let's move to the next problem. Next is problem number 5. Okay, now look at that. The problem number 5, 2 cos square x by 2 sine square x. So 2 cos square x by 2 sine square x equal to x square plus x to the power minus 2. On the left you have trigonometric, on the right you have some algebraic. So this can be the solution. This is a very mixture type of problem. So I will show you, actually in my presentation I have chosen so many different types of problems so that you have a broad knowledge of that, how to solve. Okay, now on the left you have trigonometric, on the right you have algebraic. Now let's first simplify this portion. On the left, if you simplify 2 cos square x by 2, if you apply submultiple, so your left will be 1 plus cos x into sine square x. Okay, that's it. Now, 1 plus cos x is less than 2, right? Okay, in this interval 0 to pi by 2, look at the cos. If you take the diagram for cos, this is your cos, this is your pi by 2, and this is your 1. And if your cos is in 0 to pi by 2 in this range, then cos x must be less than 1. So 1 plus less than value, that will be less than 2. That's the reason why I am writing 1 plus cos x less than 2. Okay guys, so 1 plus cos x less than 2. What about sine square x? Sine square x is always less than equal to 1. Sine square x is, I can write sine square x is always less than equal to 1. Okay, 0 to 1 always. So sine square x is less than equal to 1. So if you take the product, that product will be less than 2. Okay, got it? So let me write in a space. Let me take a space. So I'm writing 1 plus cos x into sine square x less than 2. That I am writing. Why? I have explained that why 1 plus cos x is less than 2. That is very clear. Because if you can draw the diagram of cos x, so every time, dear students, if you have the graphical knowledge, that will be fantastic for you. Very soon, in the next class, I will give you the graphical knowledge. Don't worry about that. So graph, picture means 1,000 words. So if you know the graph, you have everything with you. So 1 plus cos x is less than 2 and sine square x less than equal to 1. So if you take the product, that product will be less than 2. That's it. Now your RHS is x square plus x to the power minus 2. Let me write x square plus x to the power minus 2. So I will apply a arithmetic mean greater equal to geometric mean here. So I will explain all obviously for all of you. What is arithmetic mean? Arithmetic mean of two numbers will be a plus b by 2 and geometric mean will be root over ab. That's called geometric mean and this is called arithmetic mean for your knowledge. So arithmetic mean is always greater equal to geometric mean. So in this case we can write using that knowledge x square plus 1 by x square by 2 greater equal to, it will be greater equal to, if you take the product square root of 1 by x square into x square, that will be 1. So you have x square plus 1 by x square more than or equal to 2. Okay, so your right hand side is more than equal to 2, but your left hand side, this is your LHS, dear. This is your LHS. LHS is less than 2. So that is not valid. No x, no values of x for which this equality hold. So the given equation is not possible for any real value of x, because your right hand side is more than 2, greater equal to 2 if you cross multiply this applying AMGM, and your left hand side is less than 2. So these two are not, the given equation is not possible for any real value of x. Okay, got it? So what is your option? Option will be A, no real solution. No real solution. Okay, dear? So this is the case where you have trigonometric function. On the right, you have some polynomial or some algebraic polynomial, anything. So this type of problems can be dealt with like that. If your left hand side has a different inequation, on the right you have a different inequation. So that doesn't satisfy actually. Next, I will go to number 6. Yeah. So for number 6, let S is a set containing x belongs to the interval minus pi to pi. X is not equal to 0, not equal to plus minus pi by 2. The sum of all distinct solution of the equation, sum of all distinct solution of the equation, this in the set S is equal to, you have to find out all the distinct solution of the equation this. So first of all, you have to simplify this. Sec x you can write 1 by cos, cosec x 1 by sine, tan x is in terms of sine by cos, cot x in terms of cos and sine. So if you simplify, you have 3 root 3 sine x. If you do the LCM also, I'm just writing the simplified form, 3 root 3 sine x plus cos x equal to 2 cos 2x. Okay, everybody, 2 cos 2x. And left hand side you can write, let me write this in a space. Yeah, you have root 3 sine x plus cos x equal to 2 cos 2x. Okay, 2 cos 2x. Now this is nothing but your left hand side, if you take 2, okay, root 3 by 2, if you write root, if you apply the trick, if you have a root 3, you have to put, you try to put this in an angle. So you have half cos x equal to, you are taking 2 cos 2x. Okay, so you can write, so root 3 by 2 is nothing but your cos pi by 3, sine pi by 3, and this is cos pi by 3. So you can write this is as cos x minus pi by 3 in terms of cos x a minus b, cos a cos b plus sine a sine b, that is your cos a minus b, and on the right you have cos 2x. Okay, so you can write 2x equal to, you can apply the general solution, 2x is equal to 2n pi plus minus x minus pi by 3. That's it. That is the solution. If you take the plus, you have a solution. If you take the minus sign, you have another solution. So you have a set of solutions, set of general values. Now let me substitute. So if you apply plus sign, you have 2n pi minus pi by 3. That's the solution. And if you apply negative sign, you have x equal to 2n pi by 3 plus pi by 4, pi by 9. Sorry, this is the thing. So now you look at that, my dear students. You have a range. Sum of the values, you have to calculate the sum of all distinct solutions. So in that case, you have to substitute the values which satisfy the range minus pi to pi, Look at that, minus pi to pi. So let us substitute n equal to 0. For n equal to 0, you have x equal to minus pi by 3, pi by 9. Okay, two values from the first and from the second. You have two values, from the first and from the second. If n equal to 1, you have x equal to 5 pi by 3, which doesn't satisfy, right? Which doesn't satisfy the range. So you can't consider this. If and the second case, you have 7 pi by 9. 7 pi by 9 you can consider that lies between minus pi to pi. And for n equal to minus 1, you have to think about the negative integers also. X equal to minus 5 by 9. Minus 5 pi by 9, sorry. So that's all. You will see that n equal to 0, n equal to 1, and n equal to minus 1 will give you the solution. Other values of n will exceed the range minus pi to pi. So no need to consider those values. You don't have to worry about that. So you have those values only that satisfy the range minus pi to pi. Now what is the sum? You take the sum of these values, minus pi by 3 plus pi by 9, 7 pi by 9, minus 5 pi by 9. So if you consider the sum, your sum will be 0. Look at that, minus 5 by 9 plus 7 pi by 9. That will be 2 pi by 9. 2 pi by 9 plus pi by 9. That will be 3 pi by 9. That is pi by 3. Pi by 3 minus pi by 3, that will be 0. So your sum will be 0. So you are adding these 4 values only. So your answer will be 0. So where is the option? Your option will be C. Okay, dear students. So this is problem 6. Let's move on quickly to problem number 7. Yeah, that's very interesting problem. Currently it is in the JE paper. After NTA took the charge, it was in the paper. So the number of roots of the equation 81 to the power sine square x plus 81 to the power cos square x equal to 30 in 0 to pi. So you have to calculate how many possible values are there. So you can write cos square x as 1 minus sine square x, right? So I'm writing this 81 to the power 1 minus sine square x equal to 30. So if you consider the, let me consider the space for you. So you have, if you now let 81 to the power sine square x as t. Let 81 to the power, you can convert to the cos also. So let it be t, then it will be t plus 81 by t, okay, equal to 30. That will be the equation using the indices, okay. So you have, that makes sense, okay. So you have, if you substitute, you have t plus 81 by t equal to 30. Now this is quadratic, simplify. So if you simplify, t square minus 30t plus 81 equal to 0. So 81, that means 27 into 3. Okay, now we can write t square minus 27t minus 3t, that makes 30, plus 81 equal to 0. So you have t minus 27 into t minus 3. Okay, everybody, t minus 3 equal to 0. So you have t equal to 27 and t equal to 3. Either t equal to 27 or t equal to 3. So if t equal to 27, you have 81 to the power sine square x equal to 3 cube. So this in this case you have 3 to the power. So you can write sine x, sine square x is equal to 3 by 2 in this case, first case, okay, because you have 4, okay, 4 sine square x. So you have this sine square x is equal to 2, okay. So sine x equal to, in this case you have plus minus 3 by 2 using the indices. Sorry, this will be 4. I made a mistake because 3 to the power 4 is 81. So this is plus minus 3 by 2, root 3 by 2, because 3 to the power 4 is 81. So 4 sine square x equal to 3, that will give you sine square is equal to 3 by 4, correct? This is, in this case you have similarly 81 to the power sine square x is equal to 1, 3 to the power 1. So in this case, you have sine square x is equal to 1 by 4. And you have sine x is equal to plus minus half. So look at that, four values of sine. Okay, 4 values of sine. Now sine x is equal to 3 by 2. So you have the interval 0 to pi. Look at that. You have the interval 0 to pi. Range is 0 to pi. In that range only. So in that range you have sine x equal to root 3 by 2. That is equal to sine pi by 3. Okay. And or sine pi minus pi by 3. In the second quadrant also, you can take this angle to second one. The second quadrant you have 2 pi by 3. So sine 2 pi by 3 also the value root 3 by 2. Okay. And 2 pi by 3 satisfies the range 0 to pi again. So in this case you have pi by 3 and 2 pi by 3, two values. And you have sine x is equal to half. Sine x is equal to half. That will give you sine pi by 6 and or sine pi minus pi by 6, second quadrant. So 5 pi by 6. In this case also you have two values, pi by 6 and 5 pi by 6. Okay. I'm not considering the negative values because it will exceed the range 0 to pi. So you have 4 values only, pi by 3, 2 pi by 3, pi by 6, 5 pi by 6. So your option will be B, 4 values, 4 solutions. Okay, everybody. So this is your problem number 7. Now let's move to quickly problem number 8. Yeah, that's it. That is also very current problem in JEE paper. Okay. Now you have e to the power cos square x, cos to the power 4x, cos to the power 6x, etc. This is an infinite series. And ln2, log 2 satisfies the equation this, then the value of this you have to find out. It looks very complicated, but no, not that. It is very easy. Now look at that. You have an infinite series e to the power. So this is GP actually. You look at that. GP, geometric progression. Your common ratio is less than 1. Cos square x mod cos square x is less than 1. So your common ratio is R, and you know that you have an infinite GP A plus AR plus AR squared, etc. And the sum of this infinite GP is A by 1 minus R. So we will apply that. Okay. We have to apply this one. So in this case you have, sorry, yeah, let me apply this one. Cos square x. So you have e to the power cos square x plus cos to the power 4x, etc. and you have ln2. Okay, and that is equal to e to the power 1 by 1 minus cos square x, applying the GP, infinite GP formula. And obviously you have a cos square x outside, e to the power cos square x into 1 by 1 minus cos square x ln2. So that will be e to the power cot square x ln2. Okay, and you can write this e to the power ln2 to the power cot square x, e and log e base and e to the power ln, that will be simply 2 to the power cot square x using the properties of log. So that is the thing, 2 to the power cot square x. Now you have that equation t square minus 9t plus 8 equal to 0. You have this equation. Okay, so that will give you if you solve t equal to 1 comma 8, just factorization. Okay, so 2 to the power cot square x equal to 1, that means that is equal to 2 to the power 0, that means cot square x is equal to 0. Okay, and 2 to the power cot square x is equal to 8, that implies 2 cube, that is cot square x is equal to 3. So cot x equal to 0 and root 3, but cot x is equal to root 3 only. You have to take cot x is equal to root 3. Why? Because your angle should be in 0 to pi by 2, first quadrant. Look at that, it is restricted to 0 to pi by 2. So cot theta equal to, cot theta is root 3. Only solution is cot theta is, here you have theta, but I have used x, no problem. This is x, oh this is x, no problem. So cot x is root 3 only. Cot x is root 3. Why? Because it satisfies this. You have to discard the other values, that is negative and 0. So in this range. And what is the expression you have? 2 sin x by sin x plus root 3 cos x. Let me write this. 2 sin x by sin x plus root 3 cos x. So if you divide by sin x, numerator and denominator, it will be 2 plus 1 plus root 3 cot x. So cot x will be root 3. So 2 plus 1 plus root 3 into root 3, that will be 2 by 4, and the answer will be half. That's the answer. So you are using simply the GP, infinite GP, using logarithm property and using quadratic, you are getting the solution, and substituting you will get the value. So half, your answer will be D. Two more problems for you. Yeah, problem number 8. The sum of all the solutions of the equation this in 0 to pi, again you have a 0 to pi, and including 0 to pi is k pi, where k is equal to, you have to find out what is k. So you have 2 cos x, 8 cos x, you can write, simplify, and cos pi by 6 plus x, cos pi by 6 minus x. You can apply compound angles, cos square pi by 6, that is the formula, minus sin square x, minus half, this is the simplified form, equal to 1. Okay, and cos square pi by 6 is 1 by 4, cos pi by 6 is half, 30 degree, cos 30 degree is half. So this is nothing but your 8 cos x, and sin square x you can write again 1 minus cos square x. So it will be simplified form is the form cos square x minus 3 by 4. Okay everybody, equal to 1. Okay, now you can do the simplification and solving. So if you simplify, you can expand, you have 8 cos cube x, because you have cos x outside, and cos square x, minus 6 cos x equal to 1. So this is, you if you take 2 common, that is 4 cos cube x. Look at that, you have a multiple angle formula, minus 3 cos x equal to 1. So this is nothing but your cos 3x formula for cos 3x everybody. So cos 3x equal to half, cos 3x equal to half. So x equal to, the general solution will be 2n pi by 3 plus minus pi by 9. Why? Because this is cos pi by 3. Okay, this is cos pi by 3. That's it. Okay, that is the solution. And you can consider x equal to 0, x equal to 2, n equal to 0, n equal to 1, etc. So you can consider this and take the sum, and you will find the answer. The sum will be 13 pi by 9. 13 pi by 9. So k will be 13. I have calculated, so I will give you hint. So this is your 13 by 9 is the answer. You can easily verify that k equal to 13 by pi, because you have n equal to 0, n equal to 1, substitute, and those values will satisfy in the range 0 to pi. You have to consider only those values. Okay. Lastly, let's come to the last problem. Yeah, the number of solutions of the order pair x comma y, where x y satisfy this. X plus y is equal to 2 pi by 3, and cos x plus cos y equal to 3 by 2. Okay, everybody. Now cos x plus cos y, you can apply the formula. You have two equations and you have to solve x. So cos x plus cos y to cos c plus cos d. So cos x plus y by 2 cos x minus y by 2. Okay, equal to 3 by 2. And look at that, if you substitute x plus y equal to 2 pi by 3, it will be pi by 3, it will be 2 into half cos x minus y by 2 equal to 3 by 2. You look at that, you have cos x minus y by 2 equal to 3 by 2. That is a value more than 1, which is not possible. Which is not possible. So there is no order pair for x comma y. So your option will be 0. Okay, everybody. So that's all for my presentation today. Thank you, all of you. Follow my lectures.